Hey everyone, it's Eben from Sonic Dreamer Studio. I've been absent some time now. I've just been so busy at work that I struggled to get to the studio, but I've managed to continue somewhat with my electronics hobby, and I decided to build what I'm calling the SDS-HUI, which is standing for Sonic Dreamer Studio Human User Interface. So it's a little DAW controller that I want to control my audio software with. So yeah, it's been difficult to get to the studio. I'm just so busy for the last 2 years actually, and I hope in the next couple of months things will return back to normal. Music is what I really love to do when I have the spare time, but it's been a big struggle in the last while. Well, let's talk about my electronic hobby. Yeah, so I would say if I had to have a second job, it would be music production. And the third job, I think, definitely would be electronics. It has always fascinated me, and over the years I've learned a thing or two. You can see here some basic projects and some cheap equipment that I'm using, but at some point I did buy an Arduino kit, which helped me to understand things much more as well. It was exciting at first, but if you have to build the project the second time, it's really not that much fun, at least to me. So I thought, it would be time to move on to the next level, which brought me to this media controller that I am trying to build. So I knew I was just going to come up with something basic, and it would be a problem with Pro Tools. They really support the avid set of hardware, so that was one of the things I accepted. But yeah, so I started making plans of what I would want, which is really just something with a stop and start, maybe some kind of a rotating encoder, and then a couple of buttons and a display. That is what I wanted. So I took an old hard drive motor and I opened it up and used the platter and the motor to actually act as the rotary encoder. It was very easy to turn with your finger. You can see here I'm spinning it, and I'm using an op amp connected to some LEDs to show you which direction it is spinning. It is a little bit quick here. What I then did was to cut out a cardboard piece with slots in it, and I just strengthened it with a ring of copper wire and super glue, and then I took a sensor from a mouse, infrared sensor with an LED, and I tested using that. I connected that again to two red LEDs, not using a op amp at this stage, and it worked very nice. I could now also, using the encoder, turn it left or right, and the LEDs would indicate which direction it will go. So you can turn it quite slow or fast. It was picking up the signal, so that was quite cool. I then connected the setup to an op amp once again, and everything worked well. It sent a clear signal to the Arduino. You can see it here on a little oscilloscope, and Arduino then will take those pulses and convert it, depending on which one was first, from the two outputs, and it will then determine if it was spinning left or right. So that was good, and everything looked well. I then went on to the next phase, where the software would send a signal to the Arduino in order to control the hard disk motor. It should be turning slowly left or right, and I quickly found out that that was much more difficult than I expected. These motors work with something called PWM, or pulse width modulation. It's a little voltage for a certain amount of time. The voltage doesn't change, it's more the time that the voltage is applied, which turns it in a direction. It sends a signal to the coils. These are three-phase motors, so it's a pattern that has to be performed, and I did that with my code, my Arduino code. But the thing I struggled with was to do it slowly in a controlled fashion. It would always slip forward or backwards to the next notch, and it was just not practical. I had to look for something else. I ended up buying a stepper motor. A stepper motor can be precisely controlled, so that is more practical. It is a little bit complicated to control. You need a special control board for it, but that was the plan. So I ended up connecting the stepper motor to a control board. It's called the Big Easy Driver, which I actually tried to build a version myself with some MOSFETs. Turned out to be a disaster. So I've got software that controls this, accelerating, decelerating, all work nicely. That bottle cap or lid you can see here, I turned it into a rotary encoder with those little slots, and then I mounted it on top of the motor. And next I would be using the actual parts from the mouse for the sensing through those slots onto this stepper motor. So everything looked good. I thought that was going to be the answer for my problem. Here you can see I've added a little copper wire so that I could touch it on the platter, and that would stop the motor from turning, and I would override with my left or right motion from my finger. At the end I had to think of something else. This didn't work well, it wasn't sensitive enough, and I had to make another plan. It just wasn't reliable. So I ended up trying something else, which was using that same sensor and putting some infrared LEDs across on the other side. And the idea was that if I could mount that on the casing where the platter would be, I could interrupt the signal, and it would then send a signal to the motor through the software to stop it. But that was not really practical. So I had to make another plan. This was just not working well. Another thing was that the NEMA 17 motor was a little bit big. It was hard to turn with one finger. Obviously that is when the power was off. So I bought a NEMA 14, which is smaller. You can see here I can actually turn it just by turning the shaft itself. So that was more practical to use. I also went back to the idea of touching the platter to make it stop. The same mechanism as before, but this time I used the touch sensor module, but it did not work that well. It was too prone to interference. Got a little plastic box, made some lines. I'm going to cut in holes for the rotary encoder, and that square part is for a LED screen that I'm going to fit. Here you can see everything is fitted together, and I've used some hot glue and also some epoxy for the motor. Next I put the power supply on a cutout perforated board that I've made. Then the next step was to actually go and design the circuit, and after that I collected all the parts that I needed and soldered that onto the perforated board. Next I have a smaller Arduino where all the code would be on that I've tested. That would be going inside the box as well, and then I have to have some buttons. The buttons would be controlling everything, and also the menu options on the LCD display. That was fitted, and then it was time for the main board. Things were getting crowdy. I ended up gluing the main board to the bottom panel, the NEMA driver still is mounted, and as well as the Arduino. After I've hooked everything up, I gave it power and I started testing with the program to make sure the buttons are working. And everything is hooked up, or rather glued up, and this is what its guts look like. You can see I've also mounted the Arduino left bottom there. That is a relay that would be controlling the motor by a little touch switch that I decided to put on the outside on the right hand bottom of the rotary encoder. And finally it's all together, and I started up the beast and tested the program that I spent a lot of time on, testing the buttons, and you can see it's also controlling the rotary encoder. Here I'm testing interrupting the power to the rotary encoder. This is aluminium foil that I'm touching. It's connected to the relay and that sensor will interrupt the power of the motor. Then there was a lot of time spent on me writing programs. So yes, that is one requirement. If you ever try this, you need to have some programming experience. I've been a programmer for decades, not anymore. I'm a solutions architect now, but this helped immensely. And what I had to do was getting the buttons and sensors to talk to the Arduino, the input and output ports, and there again that should be talking to another program. I used C#, a console app for that, and that would go through the serial port, and then all of the commands from that would be going to Pro Tools. Now Pro Tools, I was using the Mackie protocol, and that was quite a challenge itself. There is some documentation if you hunt around, and you're going to have to reverse engineer some of the stuff, but I was doing it through a virtual MIDI port and setting up a HUI device on Pro Tools, and that worked quite well, but it is a lot of work, and what I'm going to show you now is quite limited, and I will decide if I ever continue with this, but for the moment I think I just showed that it can be done. And here it is, the pavement special in all its glory. Maybe it's more of a Frankenstein. You can see I wrapped it in aluminium tape, so it looks very old school. Yes, and it is just as limited as it appears. But it works, and it does what I wanted to. Let's see how it runs. Alright, all I did was I moved the controller up on the laptop. There it is, so that I have everything in shot. This is my old laptop. It's got Pro Tools 11 on it. I'm using this machine mainly for my electronic hobbies like this. And the project in here is just a video clip that my daughter used for training back in the day when she learned Pro Tools. I don't have the codec for the little, it's actually an ad that they try to work with. I just don't have that. It's fine, it will work for this project. So of course the controller works with USB towards the computer for the HUI messages in and out. There's a charger for it, adapter, and then I've got a Pro Tools iLock, old iLock here. I'm actually still using that for my subscription. So let's see how the controller works. So there you can see the menu. It's not that stable though, but if I press, let's do a return to 0, which is the bottom one here. You can see it's gone back now, starting at 0. And then if I press play, it will start. You can see there it's running.
It's making a sound like rah, rah. No, rah. Yes.
I'm going to press stop. There's the stop button. So I can of course also do forward and reverse. So let's try forward. And the little disc here spins. Yeah, it's...
Yes. What? Jumps.
I'm going to reverse. Press stop again. And then I can also arm recordings. There's no tracks being armed. If you see, if I disable that, I can also do some scrubbing. Okay, that's it really. And then of course I can reset it. I've got a soft reset. Quite fast. But yes, there's my little project, and I think now it's time to show you the parts for the code. So behind the scenes I'm running control app there. It's all C# driven. And if you have a look at what I'm doing here, I'll click play.
No. Yes.
Yeah, so there are all kinds of commands that happens when I do that for debugging. That's it. So this is the end of my little documentary. I have learned a lot. I had a lot of fun. Yeah, there was some frustration. One of the things I wanted to get to was to make the device control the faders in Pro Tools by using the rotary encoder, and then vice versa. You know, if the fader moves there, it should be reflected on the device. But I never got to it. I've started, I've got the commands, but yeah, it was so tedious, I just decided to move on. I think an important lesson to me was never buy a white car and tell people you're going to paint it red yourself. Of course, I'm just joking. I knew what I was in for from the start, so that's fine. The other thing I would like to mention is that there's a reason why these type of devices are kind of pricey. It has to be reliable and functional across different operating systems and then the applications. You don't want to sit in the middle of a session and something crashes. So that is why I do understand that. A final word would be that if you notice perhaps in that wide screenshot of my control room, there are some devices there that is in line with what I've demoed. Of course, state-of-the-art stuff. So yes, I did invest in something, and I'm actually going to have a video on that, kind of an unboxing video. There are some interesting things that I'll share in there around that. A very interesting story actually. Great stuff. It's been great fun. I hope you enjoyed it as much as I did. Yeah, cheers.